In the previous video, we solved the systems of equation via substitution, where we solved our easier linear equation for y, and then we took that value of y and we replaced y with what value of y is in terms of x, and we ended up then to do our math and we got our xy coordinate. Today I want to talk about by elimination. So elimination means you want to get rid of something. So I know this is a system because I have my curly braces. So I'm going to look at my top linear and my bottom linear equation. So I want to decide which one is easier if I were to add the top to the bottom, which would be the easiest variable to get rid of. I'm looking right here at this y and this 4y. I know if I multiply this by 4, then they're going to be almost the same. So in fact, if I multiply it by -4, my y's would turn into a 0. So if I'm going to multiply the top y by -4, I have to do that for the entire linear equation. So this is what I'm going to do. I'm doing 2x plus y is equal to 10. I'm going to multiply this whole linear equation by -4. So when I do that, that's going to give me -8x minus 4y is equal to -40. So I've quadrupled all my terms. So these are equivalent. I haven't changed the value. So this is -8x minus 4y is equal to -40. So I just want to point out that that was the same as my top. So those are all equivalent. Everything in yellow has the same value. And then I'm just going to copy this one on the bottom. 3x plus 4y is equal to 12. So now if I add the top to the bottom, notice I have my like terms lined up. I'm going to have -8x plus 3x, which gives me -5x. -4y plus 4y gives me 0. And then this equals -28. So now I'm going to solve for x. I'm going to divide both sides by -5. And then I end up getting x is 5.6. And that was the value that we had gotten on the previous page. So you can see by elimination, sometimes it means doing less work. So just like in the previous problem, I have to take this value of x and I have to put it back into one of these and I have to solve for y. So I'm going to pick the top one. So I'm going to take this value of x and I'm going to stick it in to my 2x plus y equals 10. So that means then I have 2 times 5.6 plus y is equal to 10. So that gives me 11.2. So this is 11.2 plus y equals 10. I subtract 11.2 from each side. So then that gives me y is equal to -1.2. I'm going to write this as a coordinate. So my answer, which I'll call my solution, is when x is 5.6 and y is -1.2, both of these equations will be true. And you can see that was the same answer that we had gotten doing it the other method. So the last thing I want to show you has to do with, let me just go ahead and box this in as that is our solution, is by graphing. Okay, so let's put down here by graphing. So by graphing, I just want to make sure you understand, I mean in the calculator. So that means I have to get both equations equal to y. So we have already done the first one, so we had 2x plus y is equal to 10. So on the previous sheet, previous example, I had solved for y. Okay, so that's one I'm going to put into my calculator. Then I have 3x plus 4y equals 12. So this one I have to solve for y. So I'm going to subtract 3x from both sides. I get 4y is equal to negative 3x plus 12. I'm going to divide by 4. So I get y is equal to negative 3/4 x plus 3. So that's the other one that I'm going to put into my calculator. In fact, I'll put this in as y1 and put that in as y2. So when I do that, clear everything out of here. I already have that in. I'm going to go ahead and graph, and we've done something like this before. And we see that we have an intersection. So the intersection should be 5.6 and negative 1.2. So I'm going to do second trace. I'm going to do the intersect, which is 5. And it's close. If it's not close, I would move it. I'm going to go enter, enter, enter. And it does give me 5.6 and negative 1.2. So that's my answer. Because I have two variables, an x and a y, I'm going to have two variables, an x and a y.